Okay, so today we'll be talking about parabolas again, but now we're going to focus on parabolas that are not centered at the origin. So if you remember the formulas from yesterday, the formulas for today when it's not centered at the origin are exactly the same. The only thing is that now we are having a shift with the vertex. So the vertex is not at 0, 0, but now it's going to be at a different location. So for example, or these are four equations, opens right, opens left, opens up, and opens down. And these equations can be used to graph a parabola that is not centered at the origin. So let's talk about what an example graph would look like. So for example, if this is your coordinate system, right? Now we will have a parabola that can be a vertex where the vertex is HK. Okay? But however, once you know the vertex, to find the focus in the directrix, if you know what A is, then you know that that's the distance from the vertex to either the focus or the directrix. So this would be the focus, and the directrix would still be on the other side. Okay? So it's basically the same thing we did yesterday, but now we are just adding a shift for our vertex. So let's look at example 1. Find an equation of the parabola with vertex at -2, 3 and focus at 0, 3. So we could use this graph to help us. If my vertex is at -2, +3, let's go ahead and graph that point. And then if the focus is at 0, 3, let's go ahead and graph that point. Remember that the parabola will hug the focus, so I know it's going to open to the right. So I know this is an opens right parabola. Now, you could use the formula from above, but I want to show you that you do not have to really memorize these formulas up here. You just have to know the formulas from yesterday. And if you remember, the opens right formula from yesterday was y squared is equal to 4ax. But now since our vertex is not at 0, 0, my new equation will just be y minus k squared is equal to 4ax minus h. So now I can go ahead and put all the information that I have in this problem into this equation. I know the vertex is at -2, 3. So the vertex is at -2, 3. And if you look back at your graph, the vertex is 2 units away from the focus. So that means, same thing from yesterday, that A is equal to 2. So now we just plug everything into the equation, and we will get that y minus 3 squared is equal to 4 times 2, because A is 2, x plus 2. And so the final equation for this parabola is y minus 3 squared is equal to 8x plus 2. And that is your equation of this parabola. Okay. Now, we need to graph. That's the second part. So just like yesterday, we are going to go ahead and find the latus rectum. Remember, the latus rectum is how wide the parabola is at the focus. So here, the focus is at x equals 0. And now you have to remember, do I use the x value or do I use the y value? Well, since this parabola opens up, it opens to the right, we need to know how wide the y opening is. So we're trying to find y, so that means we have to plug in x equals 0 to find the y values at the focus. So if I plug in x is equal to 0 here, so this is the lattice rectum. Okay. If I plug in x equals 0, I will get y minus 3 squared is equal to 8. And then if I plug in 0 here, 0 plus 2, so I'm substituting x is equal to 0. This will be 8 times 2. And so this will become y minus 3 squared is equal to 16. I take the square root of both sides, and I'll get y minus 3 is equal to plus or minus 4. And so now you just solve for y. So y is equal to 3 plus or minus 4. So that means y is equal to 7 and y is equal to negative 1. So that means at this focus, at x equals 0, the opening of the parabola will go from 7, y equals 7, to y is equal to negative 1. And so your parabola will start at this vertex and will open to the right and will go through the points 0, 7 and 0, negative 1. That is that parabola. Okay, so you should go ahead and try the DIY on your own now. So you could pause the video to try it on your own. And then when you are ready, just go ahead and resume the video. So the DIY, you want to find an equation of a parabola with vertex 2, negative 3 and focus 2, negative 5. So whenever you do these problems, you should always just use the graph to help you to visualize what type of parabola you're going to have. So if your vertex is at 2, negative 3, and your focus is at 2, negative 5, remember, since we hug the focus, it's going to open down. So I know this is an open down parabola. And if it opens down, then my formula, so remember from yesterday, our formula was x squared is equal to negative 4ay. So now if we just move the vertex, it is going to be x minus h squared is equal to negative 4a y minus k. Remember that in the vertex, h will always be attached to the x and k will be always attached to the y. So now I just look at my problem here to see what the vertex is. The vertex is at 2, negative 3. And I know my a, once again, is the distance from the vertex to the focus. So here, a is equal to 2 again. So if I plug everything in, this becomes x minus 2 squared is equal to negative 4 times 2 y plus 3. And then this will become x minus 2 squared is equal to negative 8 y plus 3. And that is your equation for this parabola. Okay. Now, next thing, we need to graph it. So we need to find the lattice rectum. So now since the parabola opens down, the lattice rectum, we are trying to find the x values. So we have to plug in the y value of the focus. So for the lattice rectum, the focus is located at 2, negative 5. So we're going to use y is equal to negative 5. So if I plug this in, I will get x minus 2 squared is equal to negative 8, negative 5 plus 3. And so this is x minus 2 squared is equal to negative 8 times negative 2. And so x minus 2 squared is equal to 16. I square root both sides, and I'll get x minus 2 is equal to plus or minus 4. If we solve for x, I'll get x is equal to 2 plus or minus 4. And so my two answers here are x is equal to 6 and x is equal to negative 2. So that means at our focus level, which is y is equal to negative 5, I will have x is equal to 6. So make a point at 6, negative 5. And then you will also make a point at negative 2, negative 5. And then so my parabola starts at the vertex and will open down. And that is my parabola. Okay. Now the next example, you won't really be tested on this, but let's say in the future, you might want to graph these sideways parabolas. And so in order to use it in a graphing calculator, what you have to do is if you enter in the graphing calculator, it will always say y is equal. So if you have a parabola that looks like this, you have to solve for y. So in this case, the first step that I have to do is I have to square root both sides. So if I square root this and this, the square and the square root cancel on the left, and I'll have y minus 3 is equal to the square root of 8x plus 2. But remember, since we took the square root in an equation, there needs to be a plus or minus here. So now if I just solve for y, this becomes y is equal to 3 plus or minus the square root of 8x plus 2. Okay. So this is the formula for your parabola. So when you enter it into the calculator, there is no plus or minus. So you actually have to enter the plus equation into y1. And then y2 will be the subtraction part. Now, if we move on to example 3, we have one of these analyze the equation problems. And if you remember from yesterday, whenever we're analyzing the equation, you have to find the vertex, find the focus, and find the directrix. You need to find all three. So you don't necessarily have to graph it, but this graph can definitely help you determine the different properties of the parabola. So the first thing that we have to do is see which variable is being squared, and that's x squared. And so the procedure is whichever variable is being squared, we have to complete the square with. So the first step is to move anything that is not the completing the square variable to the other side. So I'm going to move the 4y to the other side. So I get x squared plus 4x is equal to 4y. I'm going to complete the square in the variable x. And remember to do that, we take the 4, we divide it by 2. That's 2, and we square 2. 2 squared is 4. So this is x squared plus 4x plus 4. But remember, whatever you do to the left side, you have to do to the right side. So the right side becomes 4y plus 4. So now we have to get it into the equation that you're used to for this chapter so that you're able to find the focus, the directrix, and the vertex. So the left side just becomes x plus 2 squared. That's its factored form. And on the right, we can factor this to be 4y plus 1. And now you have an equation in the form that you are familiar with in these past 2 days. I know the vertex based on this equation is going to be at -2, -1. Now remember how the form of this equation is written as x plus h squared is equal to 4a y minus k. Oh, sorry, x minus h, y minus k. So in this problem, since there's a 4 here, I know a will be equal to 1, okay? Whatever this number is, you just make it equal to 4a and you find your a here. So if this number was 8, a would be 2. If this number was 12, a would be 3. If this number was something that can't be divided by 4, but let's say it's 6, I just make 4a equal to 6 to find my a. So a here is equal to 1. So now, like I said, you could use this graph on the right to help you. Some of you will be able to get the focus and the directrix just by looking at this. But if you need the graph, use it. You know that this is -2, -1 is your vertex. Based on the formula here, this opens up. And remember, how do you know it opens up? Well, it's an x squared parabola, and it's positive here. So if it opens up, right, then I know my focus will be above the vertex, and I know my directrix will be below the vertex. And since A is 1, my focus will just be 1 up from the vertex, and the directrix will be 1 below the vertex. So I know my vertex is -2, -1. My focus is -2, 0. And my directrix is the line y is equal to -2. So once again, you need all three of these things when it tells you to analyze the equation. You need the vertex, you need the focus, and you need the directrix. Okay, so take some time to do the next DIY. Pause the video. If you need help, you could just unpause it to see me doing the problem. So now we have to analyze the equation. Y squared minus 4y plus 4x plus 4 is equal to 0. Since the y is being squared, that's the one we're going to complete the square in. You're going to move everything to the other side. So this will be y squared minus 4y is equal to -4x minus 4. I'm going to complete the square in the y, so this will become y squared minus 4y. -4 divided by 2 is -2, and I square that, that's plus 4. But remember that you have to add 4 to the right side. Now the left side just becomes y minus 2 squared. And the right side, the -4 and 4 cancel, so I'm just left with -4x. So now this parabola, since it's y squared, I know it opens right or opens left. And since there's a negative here, I definitely know that this opens left. Okay. And so now I know my vertex because this is the equation of the thing. Now don't be thrown off here. If it's an x by itself, then the x value of the vertex is 0. And since there's a 2 here, my vertex is going to be 0, 2. Now, A, once again, will be 1. Because remember, my original equation should look like this. Y minus k squared is equal to -4a x minus h. And since this is -4 and this is -4, a has to be 1 in this case. So a is 1. So that means the distance to the focus from the vertex is 1. So what we're going to do is I'm going to use my graph to help me. If my vertex is at 0, 2, and I know this opens left, then I know my focus has to be to the left of the parabola. So the focus is going to be -1, 2, and my directrix is 1 the other way. So my directrix is the line x is equal to 1. Okay. So now next thing that we are going to do is you are going to find the equation of a parabola if you're given two properties of the parabola. So it says find the equation of a parabola with vertex 1, -1 that contains the point 0, 1 that opens up. So I know my opens up parabola is going to be x squared. So it's going to be x minus h squared. And since it opens up, it's going to be positive on this side. Okay. So now what I'm going to do is I'm going to plug in the vertex for h and k. And now you need to find A. So there is no information on where the focus is, right? So what you're going to do is you're going to use this point as another random point on the parabola. Now, if this point satisfies the equation of the parabola, this will be an x and a y that will fit the equation of your parabola. So you have the h and k and you have the x and y in your parabola. And now you could solve for a. So this will be 0 minus 1 squared is equal to 4a 1 minus negative 1. And so if you work this out, this becomes negative 1 squared is equal to 4a times 2. So 1 is equal to 8a. If I divide both sides by 8, I get a is equal to 1/8. So now my final equation will be x minus 1, because we're plugging in the vertex, squared is equal to 4 times 1/8, right? So I'm going to put 4 times 1/8 y plus 1. Since it's y minus k and k is negative 1, this will be y plus 1. So my final equation, if I just multiply this out, is x minus 1 squared is equal to 1/2 y plus 1. Okay. So go ahead and try the DIY on your own. And then when you're ready, you could just follow along. So if I know that this opens left, then I'll know that this is going to be y squared. And this is going to be negative 4a x minus h. Okay. So now I can plug in 1 and 0 for the vertex, and I can plug in 0, 1 for my point xy, because this is a random point on the parabola. So if I do that here, my y is 1, my k is 0, I'm trying to find a, my x is 0, and my h is 1. So this becomes 1 is equal to negative 4a times negative 1. So 1 is equal to 4a, and so a is equal to 1/4. So now if I'm going to find the equation here, I just plug 1/4 into here along with my vertex. So this is y so since it's minus 0, I don't need to put the minus 0. This will just be y squared on the left is equal to negative 4 times 1/4 x minus 1. And if I work this out, this becomes y squared is equal to negative x minus 1. And because the 4 times 1/4 is just 1. Just remember this why is this y squared and I'm not adding or subtracting? Well, because here my k is 0, so y minus 0 is just y. Okay. Now let's go ahead and move on to some applications of this. So one of the really cool things about parabolas is that it helps, there are some practical uses here. So for example, one of the things that can happen is, let's say we have a flashlight, and if we put a light where the focus of the parabola is, once you turn on the light, it will shine from that light bulb, and since it's at the focus, what happens is that the focus will direct the light to the parts of the parabola. And when it directs it to the parabola, the light comes out in parallel lines to provide the strongest light. If you put the light not at the focus, what happens is you don't get the strongest light because it's not hitting the parabola at places that will form parallel lines when the light emits. Same thing happens when you are when you have like a satellite dish. If you look at satellite dishes, they are shaped like parabolas. And the reason why is that the signals that come from the satellites up in space kind of hit the they hit the dish of your satellite dish. And what happens is that when they hit the dish, the rays go back to the focus of the dish, which is the receiver, and that's how you get the signal for your TV and stuff like that. So let's look at example 4. It says a satellite dish is shaped like a paraboloid of revolution. Now, it's paraboloid because it's not just a parabola, it forms like a 3D object, and that's what you call a paraboloid. So what happens is the signals that come from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. This is what I was talking about earlier. The signal comes and hits the dish, and then it all goes to a receiver that inside the dish. So now they are asking if the dish is 8 feet across and its opening is 3 feet deep at its center, at which position should the receiver be placed? So it's kind of hard to see in your drawing here, but what's happening is this is 8. This is 8, and the dish is 3 feet deep. So it's 8 feet long, 3 feet deep. And they are asking, where should the receiver be placed? Whenever you're asked that question, they are really just looking for the focus of the parabola, because like I said earlier, the strongest signal will be when the signals hit the focus. So you want to know where to place the focus to get the strongest signal. So what we're going to do now is we are going to take this parabola and we are going to put it into a coordinate system that is very friendly for us to use. Now, we are not going to place, what we're going to do is, it's easier for us to put this parabola where the vertex is at the origin. So we don't have to deal with the y minus k and h minus x minus h stuff. So what we do is we're going to take this parabola and we're going to put it on a coordinate grid where the vertex is at 0, 0. So what that means is if the parabola is 8 across and we put the center at 0, 0, then I know the end of this parabola will be at x is equal to 4, right? And this will be negative 4. And if the satellite dish is 3 feet deep, then I know the y value here is going to be 3. So I know this point here is 4, 3. And so now we could just do what we just did in the last examples to find the focus. So the way we're going to do that is this is an opens up parabola centered at the origin. So I could just use x squared is equal to 4ay. So the question is where to place the focus. So we are trying to find a here, but I do know another point in the parabola. So we're going to plug 4 and 3 in for x and y respectively. And this will become 4 squared is equal to 4a times 3. And so this becomes 16 is equal to 12a. If I divide both sides by 12, I get a is 4/3. And so that's the distance from the vertex to the focus. And so my focus is going to be exactly that. It's going to be 4/3 away from 0. So since it opens up, my focus is going to be up here at 4/3. Since it's a real world problem, we are not going to put 4/3. You could write it as a decimal, or you could even just write it as a mixed number. So the receiver should be 1 1/3 feet from the base. Okay? So go ahead and try the DIY. It's a very similar question. So you could pause the video now, and then when you're ready, go ahead and play the video. So just like the previous problem, if we center the parabola at 0, 0, I know this point here will be, this is going to be 5 since it's 10 across, and this is going to be 4. So this point is 5, 4. I could just use x squared is equal to 4ay. This becomes 25 is equal to 4a times 4. So 25 is equal to 16a. You divide this by 16. And so A is whatever 25 divided by 16 is. I don't have a calculator on me, but that is how far your receiver should be from the base of your parabola. Okay. So now let's do the last question. The last question is very similar to this question, the previous questions. And I don't want to interrupt the video. I don't know what will happen if I try to get my calculator on the phone. So I'm not going to be able to calculate some of the things here. But let's go ahead and try to see what will happen here. So what happens is you have a suspension bridge, and they already tell you that it's 600 across. So what's going to happen here is I'm going to go ahead and put my vertex of the parabola. Oh, sorry, that's a bad drawing. What's going to happen is I'm going to put the vertex of my parabola at 0, 0. If it's 600 across, then I know the x value here is 300, and I know it's 80 feet up. So what they want us to do is they want us to find the height at 150 feet. Well, in order to do that, we need to get the equation of the parabola first, and then plug in 150 for x. So if I know the parabola goes to 380, this is another x squared is equal to 4a y parabola since it opens up. So this is going to be 300 squared is equal to 4a times 80. And so 300 squared is 90,000. And this is going to be 320a. If I divide both sides by 320, I don't have a calculator, so what I'm going to do is I'm actually going to reduce this fraction. I know a will be equal to, well, I know the zeros are going to cancel. 4 should be able to go into both. So if I divide the top by 4, I should get 2, 2, 5, 0. Let me just double check. 4 goes into 9 twice. 4 goes into, that's twice, 2, 5, 0, yeah. All over 8, okay? I could still reduce that, so I think this is going to be 1, 1, 2, 5 over 4, and I think that's as far as it can reduce. But you could just go ahead and plug that into your calculator to get a decimal. It will work either way. I just don't have a calculator, so I'm going to leave it as that. And I could actually, never mind. Let's just forget it. If I plug that back in, I'll get x squared is equal to 4 times 1125 over 4 y. And look at that. It's actually good that I left it as a fraction because the 4's will cancel. And I know my equation will just be x squared is equal to 1125 y. So that's the equation of my parabola. So now if I want to find the y value for this question, I'm just going to plug in 150 for x. So this is 150 squared. And let me just quickly do that here. So this is 0, 0, 5, 7. And this is 0, 5, 1. So this will be 22500 is equal to 1125y. And then I divide both sides by 1125. And y is equal to, it's probably 20. I think it's 20. So go ahead and just double check that I got the right answer. If it's not, you could just fix it. I was just doing it in my head. So it should be 20 feet. Okay, so that's the lesson. It's basically the same thing that we did yesterday, except that you are just applying a vertex to the parabolas. And these applied questions, you actually make it easier on yourself by putting the parabola at the origin.